The volume formulas for rotation about the y-axis. We adapt the volume formulas to calculate volumes of curves revolved about the y-axis. To do so, we assume g of y is equal to or greater than h of y for y in the closed interval from c to d. Geometrically, this means that the graph of x equals g of y is to the right of the graph of x equals h of y. For the disk, the volume, we integrate from c to d of pi, and in brackets g of y, quantity squared, dy. For the washer, the volume is the integral from c to d of pi times the outer, that's g of y squared, minus h of y squared, dy. Example, form the integral for the volume of the solid generated by rotating the region between x equals 0 and x equals 9 minus y squared about x equals -1. We begin this problem with a sketch of x equals 9 minus y squared. The graph is a parabola that opens to the left and has vertex on the x-axis at 9, 0. And we also sketch the graph of x equals 0, which is just the y-axis. Shade the region bound by the two graphs. This is the region that will be rotated about the line x equals -1. Note, the vertical line x equals -1 is sketched with dashed lines. The volume we seek, v of y, is the integral from c to d of the area of the right minus the area on the left, dy. Let's algebraically find the points of intersection of x equals 0 and x equals 9 minus y squared. Set those two equal to each other. 0 equals 9 minus y squared, and that factors to the quantity 3 minus y times the quantity 3 plus y. The points of intersection occur at y equals -3 and 3. Going back to our volume formula, we now can integrate from -3 to +3, bracket, pi times the radius of the right squared minus pi times the radius of the left squared, dy. Continuing, radius of the outer or right circle is the distance between x equals 9 minus x squared and the line x equals -1. Radius of the inner or left circle is the distance between the line x equals 0 and the line x equals -1. The volume becomes, let's go ahead and pull the pi out to the left of the integral symbol, integral from -3 to 3 of the right, which is 9 minus y squared minus -1, that quantity squared, then minus, for the inner circle, 0 minus -1, that quantity squared, dy. We can simplify this. That'll take us to pi, the integral from -3 to 3 of 10 minus y squared, that quantity squared, minus 1 squared. Simplify a little bit more. Pi times the integral from -3 to 3 of 10 minus y squared, that quantity squared, minus 1. We can multiply that out, and we'll get pi equals the integral from -3 to 3 of 100 minus 20y squared plus y to the 4th minus 1. Now subtract 1 from 100, and this integral becomes pi, integral from -3 to 3 of 99 minus 20y squared plus 4y to the 4th dy. Since the integrand is symmetric about the x-axis, We can write the volume as twice or 2 pi the integral from 0 to 3 of the quantity 99 minus 20y squared plus y to the 4th dy.